Hi, this is Ms. Park, and this video is called Solving Trigonometric Equations. So I'm going to write a trigonometric equation. We'll call this question 1, and it'll be like this. It'll be solve for theta, and I'm going to say that theta can be anything between 0 degrees and 360 degrees. Okay, and I'm going to ask that for this one, don't use a calculator. Okay, so that's actually a bit of a clue for you. Don't use a calculator. So here's my question. The square root of 2 sine theta equals 1. All right, and again, theta can be anything between 0 and 360 degrees. So to solve this, we're trying to figure out the measure of angle theta. So I'm going to isolate angle theta. So first I've got to isolate sine theta. So I'm going to divide both sides by root 2. And then I have sine of theta is 1 over root 2. Now, hopefully we remember from our special triangles that the sine of 45 degrees is 1 over root 2. But I'm writing it as the related angle and not theta. And that is because when we're considering the entire circle up to 360 degrees, sine is going to be positive in 2 quadrants. So I'm going to draw the quadrants, and I know that sine is going to be positive here and it's positive here. And the related angle is 45 degrees because 1 over root 2 comes from special triangle. So let's pretend I drew this as a nice triangle, which I didn't. But anyway, now I can consider these 2 triangles. This is 1, 1, and root 2. This is negative 1, 1, and root 2. And so what I have is I actually have 2 answers. I have theta is the quadrant 1 answer, which is 45 degrees, or remember theta is measured in standard position, so there's a second answer in quadrant 2, which is 180 minus 45, so 135 degrees. And that is solving a trigonometric equation. So let's do another one. Let's take example 2, make it a little more interesting. So let's solve this. 2 sine squared theta minus sine theta minus 1 equals 0. Okay, so now again, we'll consider theta as anything between 0 and 360 degrees. So we want to look for every possible value. So we're trying to isolate sine theta. If you look real close, this looks like a quadratic equation. So if I did a little change of variable over here, let x equals sine theta, you will see that this looks like 2x squared minus x minus 1 equals 0. So we have to remember our quadratics. This one actually factors. So it is a complex trinomial, so you could use decomposition or you could do quick trial and error. And I'm just going to do quick trial and error. Oops, not 1, but 0. Where's my eraser? Don't have an eraser. Okay, sorry, eraser's not working. Okay, so here we go. There's a 1. And so this is going to be negative. This is going to be positive. Just do a quick check that that works out, and it does. There's 1. And so 2 things multiply to give 0. So I can solve this quadratic equation as this one equals 0 or this one equals 0. And so now I have x is equal to 2x equals negative 1, x equals negative 1/2, or x is equal to 1. But remember that it's not about x, it's about sine theta, so I can put this back. Therefore, sine theta equals negative 1/2, or sine theta is equal to 1. So, almost done here. We can solve sine theta equals negative 1/2, so I know that that is also a special angle. But where is sine going to be negative? That's quadrant 3 and quadrant 4. What is our related angle? Well, if we remember our special triangles, we should know which angle has a sine of 1/2, and that is 30 degrees. So now I'm going to have 30 degrees in quadrant 3 and 30 degrees in quadrant 4. So this is where I'm looking. So my angle theta is actually not 30 degrees. We're measuring from standard position. So one answer is my quadrant 3 answer. That's 180 plus 30, which is 210. The other answer is my quadrant 4 answer, which is 360 minus 30 degrees, and that's 330 degrees. That takes care of one branch. So the other branch says that sine theta is equal to 1, and probably the easiest way to do this is now that we know how to graph, we know here's sine theta, 1 is at the maximum. This period is 360 degrees. Here's 180 in the middle. This is 90. This is 270. So even without drawing special triangles, we can see that the value of sine is 1 at 90 degrees. So theta is equal to 90 degrees. And that's the only value between 0 and 360 degrees where the sine is equal to 1. So my final answer for this question is that theta equals, and now I'm going to take my 3 answers and write them from smallest to largest. And that's it. I have 3 answers to this equation. Let's give you one more. Okay, so this one's going to be, it's going to look a little bit easier, but there's something new to consider. So I'm going to give you question 3, and this says cosine of 2x equals root 3 over 2. And again, I want x to be anything between 0 and 360 degrees, so we've got to consider the entire circle. Okay, so let's look at what, first of all, where is cosine positive? So cosine's positive in quadrant 1 and quadrant 4. What angle has a cosine of root 3 over 2? So that is going to be 30 degrees. So my related angle is going to be 30 degrees. So I have a 30 degrees here, and I have a 30 degrees here. Think of the 2x as a theta. So really what I'm doing is I'm solving here, that's right over here. Let theta equals 2x. This part's kind of optional, but it might help you to think of it. It's the same as solving this equation. I'm trying to find an angle that has a cosine of root 3 over 2. So I do have a quadrant 4 angle. So I have theta is equal to, sorry, I have a quadrant 1 angle, so it's 30 degrees, or theta is equal to the quadrant 4 angle, which is 330 degrees. But we're not trying to solve for theta, we're solving for x. So therefore, 2x is equal to 30 degrees, or 2x is equal to 330 degrees, which means my x is 15 degrees, or my x is 165 degrees. So those are my 2 answers. However, this question's a little bit different because what we have is 2x, and we know that from graphing trig functions, we know that 2x has a period of 180 degrees. That k value of 2, this is a k value, is 2, it means that the period is 180 degrees and not 360. So I'm going to write that over here, but the period is 180 degrees. So what's going to happen is that my 2 answers that I found are going to be within one cycle, but that cycle only goes up to 180 degrees. So let me sketch this. I still have the 1 and the negative 1, and it's a cosine, so let's split this into 4 equal parts. So that's going to be maximum, average, minimum, average, maximum. And so I have my one cycle, but here's the question is saying find me all the values between 0 and 360. So if I'm going to have to find all the values up to 360, it means I need to add another cycle. So there's going to be more answers. So up in one cycle, I've got the 2 answers, but then for the next cycle, I'm going to go up to 360. I'm going to have more answers. So again, I'm at the maximum, average, minimum, average, maximum. And there you go. So my first answer is 15 degrees. So that's going to be somewhere over here. 15 degrees is like close there. 165 is there. But those 2 values occur again 180 degrees later because the period's 180 degrees. So this one's going to happen 180 degrees later, and the second one's going to happen 180 degrees later. So I'm actually going to have 2 more answers. So therefore, x is equal to 15 degrees plus 180 degrees, which is 195 degrees, or x is equal to 165 degrees plus 180 degrees, which is 345 degrees. So how many do I have? I actually have 4 answers. So I'm going to do my therefore statement and write them all in order. So x is equal to 15 degrees, or 165 degrees, or 195 degrees, or 345. Okay, so that trigonometric equation resulted in 4 answers. It looked kind of simple at the beginning, but there's actually 4 answers. So what did we do? We had to look at the angles around the circle, and then we had to look at the period. So we had to know a little bit about the graphs in order to get all the 4 answers. So I'm going to give you one more, and this last one is going to help with word problems. Okay, so let's do question 4. Now, question 4 is going to look like this. It's still going to be solved. Okay, but this time I'm going to give you all the stuff. Okay, so 5 cosine 2x plus 30 minus 6 equals negative 4.75. And after we do this example, I'll show you the word problem where you're going to use this. Okay, so first things first, I've got to isolate this cosine. So I'm going to go cosine of 2x plus 3 is equal to, 5 cosine 2x plus 3 is equal to negative 4.75 plus 6. And so 5 cosine of 2x plus 3 equals, okay, I'm just going to grab a calculator. $1.25. So let's go 1.25. Now I'm going to divide both sides by 5. So I'm going to have cosine of 2x plus 3 equals 1.25 divided by 5, which is 0.25. Okay, now cosine of something is 0.25 or 1/4. That is not a special angle. So I'm going to have to use a calculator here for this angle. So I'm just going to write here, use a calculator. And I'm going to say because it's not special. Okay, so what do I really have here is if I replace the 2x plus, oh, I'm sorry, it's 30 everywhere, not 3. If I replace the 2x plus 30 with a theta, then really what's being asked of me here is to figure out cosine theta is 0.25. And if I use my calculator now, I can do the inverse cosine. So cosine inverse of 0.25, but we know that that's not actually theta. It's not theta, that is the related angle. So where is cosine positive? Quadrant 1 and quadrant 4. So whatever number I get from my calculator is going to be my related angle in quadrant 1 and quadrant 4. So I'm just going to get my calculator now. 0.25, and I get 75.5 degrees. So just for simplicity, I'm going to round it to 76 degrees. That's my related angle. So there's one here and there's one here, but that's not my theta. I have 2 values of theta. So therefore theta is my quadrant 1 answer, or theta is my quadrant 4 answer. So I got to go 360 minus 76 degrees, 284 degrees. Okay, but now remember the question's not asking about theta, the question's asking about x. So I got to put my x back. So 2x plus 30 equals 76, or 2x plus 30 is equal to 284. Okay, so let's solve this. So 2x is equal to 46, x is equal to 23, or 2x is equal to 254, and so x is equal to 127. So now I got my 2 answers, x is 23 or x is 127. But once again, look at the k value. There is a k value that is 2. Okay, so I'm just gonna I'm gonna go down here and continue. The k value is 2, tells me that my x's are from the first cycle only, and each cycle is 180 degrees. So if I want to consider all my values, then let's put degrees on here. Pretend we're working with degrees. We don't really know the unit, but let's just say it's degrees. So my values are going to repeat. So here's my cosine that goes up to 180 degrees, and then there'll be another one that goes to 360 degrees. So my 2 values, so here we go, here's 180, here's 90, Okay, I'm just going to make these little tick marks so we see them. Okay, so my two values, the 23 degrees and the 127, one of them occurs here and the other one occurs here. And then in the rest of it, it will be 180 degrees later, you get the same values again. So, so period is equal to 180 degrees. So therefore also x is equal to 23 plus 180, which is 203 degrees, and x is equal to 127 plus 180, which is, let me just do that in the calculator so I don't make a mistake. 127 plus 180, 307 degrees. So my final answer is that x is equal to 23, 127, 203, and 307. Okay, so there we have it. So this is how we're going to isolate the x. We're going to use the angles around the circle to get all of the answers, and then consider the period to see if there's more answers. Now you can see that if the k was something like 3 or 4 or 5, you're going to have way more answers because you're going to have so many cycles within 360 that you'll have to consider more and more angles by adding the period to get the next answer and the next answer. So I promised you that I would show you where you're going to use this. If you look at this example, the equation looks a little bit familiar because we see these equations in word problems. So for example, here's a word problem. Okay, Dan at the wave pool. You get a bunch of information about the maximum height, the minimum height. It asks us to draw a sketch. Okay, so we're going to do a sketch and then ask some questions from the sketch, and then it's just to write an equation. When we write the equation, it looks like this. This is familiar. This equation is familiar. And so we write the equation from the sketch, and then it says, at what time is Dan 1.7 meters above the floor of the pool? So in this question, the y represents the height above the floor of the pool, and then you have all your other values, and the x is the time. So for question D, you're going to put the 1.7 on the left side, and you're solving for the x, which means that's going to be the situation where we have to set up the equation like this with the height on one side and then all the rest of the stuff on the other side, and we have to solve for the time. Okay, so I hope that was helpful. Please practice. Thanks for watching.